Hello everyone, my name is Vamika Sharma. I am from National Institute of Hydrology. The topic of my research is on evaluation of remote sensing based ET products in a semi-arid river basin, Rajasthan, India. In regions like Rajasthan, ET governs irrigation demand, yet direct ET measurement is impractical at basin level. It is too costly, too sparse. Therefore, we rely heavily on hydrological models and remote sensing products. In this study, we have compared three globally available ET products. The first is GLDAS, MODIS and GLEAM. Our benchmark model is SWAT, which is calibrated and validated using rainfall, discharge, soil, land use, land cover data. We have monthly and annually calculated evapotranspiration across all subbasins. NSC, R-square and P-bias are used as performance indicators. The key findings are, GLDAS has showed us strongest agreement with SWAT ET. MODIS has continuously overestimated evapotranspiration across all subbasins, and GLEAM tends to underestimate ET. So the conclusion so far is that if ET needs to be used for irrigation planning, then GLDAS is the most dependable option in regions like Rajasthan. Furthermore, to extend the analysis beyond statistics, we have also assessed where this ET is actually going with the help of water counting plus sheet 2. The total evapotranspiration is 19.1 BCM per year. Shockingly, only 14% of ET is beneficial, which is used in agriculture, economy or ecosystem. And a massive amount of ET, that is 87% of ET is non-beneficial, which is used in soil, which is lost from soil or intercepted surfaces. So we can say that we don't just need more water, we need to retain and redirect this evapotranspiration into productive uses. Finally, we can say that GLDAS is the most reliable data set for regions like Rajasthan, and Water Accounting Plus has added a strategic value and tells us where this evapotranspiration is going or where this is being productively used. Finally, we can say that evapotranspiration is no longer an output, it is a tool for action. Thank you.